Hello viewers, I'm Keerti Bhave. Welcome to this session on differential aeration corrosion. After going through this video, you will be able to define differential aeration corrosion, explain mechanism of differential aeration corrosion, and understand real-life situations demonstrating differential aeration corrosion. Let us begin with the definition. Differential aeration corrosion is the loss or decay or destruction of a metal when a metal is exposed to uneven supply of oxygen. It is also called as oxygen concentration cell type corrosion. It is a type of immerse corrosion, and the reactions which take place are electrochemical reactions. Let us understand how an oxygen concentration cell works. On an uneven metal surface or on any metallic surface which is not uniformly exposed to oxygen, an oxygen concentration cell is formed. The more oxygenated regions use the oxygen dissolved in the atmospheric moisture and electrons to give hydroxide ions. As there is acceptance of electrons in this reaction, this region is the cathode. From where are these electrons coming? These electrons come from the less oxygenated regions around it, where the metal ionizes and gives metal ions and electrons. As there is removal of electrons here, this region, which is less oxygenated, is the anode. How do we correlate these reactions to corrosion? Let us see these reactions once again. The loss of electrons or the formation of metal ions from metal results in corrosion of metal, which takes place at the less oxygenated region, which is the anode. That is, the anodic metal corrodes. Let us understand oxygen concentration cell type corrosion with some examples. Now, this is a metallic surface. The metal surface at one end is uncovered and therefore is exposed to more oxygen, while on the other side it is covered. This covering may be of some insulating layer, it may be a paint layer, or it may be even a drop of oil or grease or even a speck of dust, because of which the region of the metal is exposed to less oxygen. In the above situation, the covered region is less oxygenated. It becomes the anode and corrodes, while the more oxygenated region, the uncovered region, becomes the cathode and does not corrode. We will see another example. Here we can see a few machine parts where the metal in some areas is exposed to more oxygen, while in others it is exposed to less oxygen. In the fastener, in the case 2, it is the crevices where the metal is exposed to less oxygen. In the above machine part, the region which is less oxygenated, that is the crevices or below the surfaces, becomes anode and corrodes, while more oxygenated regions become cathode and does not corrode. Let us revise the concepts again. In oxygen concentration cell type corrosion or differential aeration corrosion, where a metallic surface is exposed to varying concentrations of oxygen, that part of the metallic surface which is exposed to less oxygen becomes anode and corrodes. Only anodic metal corrodes due to immersed corrosion. I hope you have understood the concept of oxygen concentration cell type corrosion or differential aeration corrosion. Wish you happy learning. Thank you.